Hi, my name's Alan McGinlay, an ecosystem architect here at Venafi. In this demo, we'd like to preview a forthcoming ecosystem marketplace solution. Navigate to the GitHub repo you see on screen for the background info you'll require if you want to try this for yourself. Alternatively, you can just watch me present a simplified version. Click through on the demo entry to show you the steps required. The section highlighted is what we'll focus on, but we advise that you take a look at the other material. This initiative was based on the notion that if we could treat TLS Protect Cloud as an extension of AWS, you could use the same rock-solid automation tools you use to deploy AWS resources, such as EC2 instances, to establish your machine identity configuration. The first of these chapters covers the Venafi one-time setup, which you should apply to each AWS account you intend to use this for. As you can see, the resources here relate specifically to IAM, but they also include an S3 bucket, which is the default location for the artifacts that will be produced. With the one-time setup in place, we can go ahead and create our first policy stack. So in this section, you'll use CloudFormation to deploy a custom resource representing a policy. Now in this context, a policy is represented by a pair of TLS Protect Cloud resources. They are an application and a certificate issuing template. Navigate to CloudFormation and click on Create Stack. On the Create Stack page under Specify Template, set the Amazon S3 URL as you see, and click Next. On the Specify Stack Details page, set the stack name to something uniquely identifiable for yourself. The first parameter is Zone. This is a logical organizational unit used for managing digital certificates. The typical form of a zone is appname/certificate issuing template alias. As you can see, this pairing aligns with the policy definition previously described. Set this value to match your personal details. As we're building a 90-day certificate, we'll add that as a suffix. We need to take a moment to discuss Certificate Authority Product. Despite not always being evident from the user interface, the CITs you create require a CA product to be specified. At the API level, CA products take the form of a triplet, as you see on screen right now. This is the built-in product, and that triplet is always available. This is fine for communication between private workloads, but you'll need an alternate CA such as DigiCert before TLS-PC can deliver any publicly trusted certificates for you. These instructions will assume that you've already set up a DigiCert test account. Unlike the built-in CA, the DigiCert CA provides a variety of CA products which you can find in their documentation. The DigiCert product supported and tested for use in this exercise is Cloud, known internally as SSL Cloud Wildcard, which gives us a certificate authority product which looks like you see on the screen right now. All other CAs and products should be considered out of scope for now. Back to the stack, we want a 90-day certificate, which is the default in this CloudFormation template, so we leave this as is. Next, we have to specify a list of domain names considered valid in the context of this policy. In my case, that's venafidemo.com. The resulting certificates can be subdomains thereof. It's important to note that your CA provider requires proof of domain ownership. Failure to provide this proof of ownership up front will ultimately cause the creation of our certificate to fail. And finally, the TLS-PC API key, which can be gathered from TLS Protect Cloud under the Preferences. Enter the key, double check for any mistakes, and then click Next. On the Configure Stack Options page, under Stack Failure Options, select Preserve Successfully Provisioned Resources and click Next. Scroll to the bottom of the review page and click Submit. After about 30 seconds, the stack will reach a status of Create Complete. With the policy stack created, we should be able to see our resources in TLS-PC. Here is the issuing template, and over in Applications, we can see our application, which is linked back to the template. Here's a diagram to show what you just did. We created a stack in CloudFormation using a template to which we provided parameters, and this created a Lambda function, and that Lambda function integrates with TLS PC to provide for us an application and an issuing template, which we refer to as a policy. The policy we just created defines the guardrails around the certificate. We now want to define the certificate itself. Back in CloudFormation, click Create Stack. Set the S3 URL as you see on screen and click Next. Give the stack a meaningful name. Use the zone parameter to link this back to the policy you just created. Through the zone, my certificate is now associated with my DigiCert account, so I can only use domains that my DigiCert account trusts. In my case, that's venafidemo.com, and I can use a subdomain as you see. By specifying validity hours of 0, I'm saying I give this up to be as long as the zone or the policy will accommodate. In that case, it's 90 days, so 0 here indicates 90 days. Renewal hours is the interval in hours between certificate renewal requests. To protect from outages caused by expiry, the value for this should be less than the resolved value of validity hours. 1,440 hours is equivalent of 60 days, so our certificate will be renewed before it expires. Use the same API key that you used before, and for private key passphrase, enter a passphrase to use when downloading the certificate's private key. Click Next to continue. If our stack fails, we want our resources preserved, so click that and Next. Finally, review the cert, scroll to the end and click Submit. If you head over to your application now, you can see you have one certificate. Click that link to show you the certificate, and here we have it. You can also view your certificate in S3, go to the outputs for the cert stack and click the S3 link. Here's your certificate and the key. Let's just review what happened there with the certificate stack. We created the stack using another CloudFormation template, which created not one Lambda function but two. One was invoked immediately to create our TLS PC resources, but also dropping that key material into an S3 bucket. Alongside that Lambda function was an Amazon Event Bridge scheduler entry. The associated Lambda function will be invoked, which updates the stack, which ensures that our certificate never expires. Since we don't have 60 days to wait around for an automated renewal, we're going to manually request one. We do this by locating the stack and clicking the Update button, using the current template, and the only parameter we need to change is this one right at the bottom, the update trigger. Set this to something random like demo, click next, and click submit. After about 30 seconds, your stack will reach a status of update complete. If we head back into TLS PC and check the certificates, you can see we now have two. One is considered old. If we head back into S3, we can also check to see that our certificate and our key have been revised. Here we have two versions. We aim to produce more demos like this, revealing how effective machine identity management can accelerate your cloud-native development and prevent application outages or security breaches. Thank you very much.